Namaskar, my dear friends. Let us talk about how we can design complex circuit in NI Multisim. So there are few occasions where you need to, utilize multiple page, like more than one page. You need to use on-page connector, off-page connector, and there are various other parts that you require to do in the schematic design. Okay, so those all design and techniques that we'll try to find out, and we'll do those things here, right? So let us open Multisim. As you can see, I have a very simple circuit here where you can see we have a voltage signal 3.3 volt with R1 and R2. And now I am going to drive this particular LED through this voltage at this node, right? So this will apply here and this base voltage will be switching on, and this is how my LED will start glowing, right? So as you can see right now, if you simulate, my LED is off. Understood? So to switch it on, I need to give a supply voltage here. So I can simply give one supply voltage, or maybe like connect it to 3.3 directly here, and then it will start glowing. But this is not a good method to do. I don't want to do like this connection. I want to give some net name and connect it like that. So for that, what you can do is you can give here, let us say, right click it, select the net, right click it, put properties, and let us say we'll put V out and show the net name though, so that you can see that. Okay, so V out is done. Similar to that, here also i'll I'll take a wire, right click it, put properties, and put V out. And this is how it is saying connect the two nets using on page connector. It is asking you. Okay, so if you want, you can use on page connector. So if you put yes, it is going to see automatically put on page connector. Understood? So automatically it has put on page connector with the same name V out and V out. And this is how, if you run it, what will happen? This particular net is connected to this place. So this is one method to do that. Okay, like put the net name here, and then they'll get connected. However, on page connector is actually necessary. Why? Because they say that you put a on page connector. Now I'm going to delete them. Okay. Let us say I'm going to delete everything. So I am going to delete this one, and by default I want to put an on page connector. So for that, what you can do is go to place. We have connectors here, and in that we have on page connector, global connector, hierarchical connector, input, output, off page connector if you have multiple pages, right? So I am going to put on page connector. So I'll put on page connector here and give the net name as V out, let us say. So my V out net name is connected. Now same connector I'll put it one more here. So it is renamed as V out 1. I'll just go and name it as V out only. Okay. And then connect it here. So both of them I have done manually, and so that it is now working. Understood? Good. So now some of the time what happens is I need to use multiple pages of the circuit. So for that, what you can do is go to place, and here there is a thing that is called as multi-page. So if you click this, you are going to get page name, this thing. So if you want, you can rename that page name or something like that. It has automatically renamed it as schematic design wiring 2. And let us say some circuit is there here that you want to connect it to page number 1 circuit. Okay, so like that we will have. So let me just open a existing circuit. We can use that and start with. So I'll just open let us say non-inverting amplifier circuit. Okay, so this one I am going to use in my page 2. Okay, got it? So this circuit I am going to use. Now what will happen is I am going to give the input signal from the first page. Okay, so let us say first page is here. I want to give some input signal, and that will get like amplified at this location. Okay, so this is how we will be using. So let us say one input signal is there here. uh, let us say I am going to place some resistor and capacitors, or what shall I do? Yeah. Let's do component placement. signal sources. Let us say some AC voltage source I am going to put here, and some like RC circuit I will use. Let us say one resistor and then one capacitor. Okay. So after this RC circuit, it will pass, it will go to page 2. That's all. So this is my signal. Let us say this is getting generated by something, some means, and we are going to use that. Just make sure that this RC cutoff frequency is much higher or much better than the required 1 kilohertz signal. So if you want, you can change that. So let us say we have this one. If I want to use like LPF, so let us say if I want to make it 1 kilo ohm and this 1.1 micro, so it is 1.59 kilohertz. So it should be less than 1.59 kilohertz signal input, then only it will work. So what I will do is, for simplicity, I will make it 100 ohm and zero point 0.1 microfarad. Okay. So I'll make it 100 ohm and zero point 0.1 microfarad. Okay. So this is how you do the circuit design. Now I am going to connect an off-page connector here, and that output will be fed to the second page input. Okay, and this is how it will get multiplied. Understood? So I'll just remove this name also. uh, let's say delete it, or Control Z, and then come back here, properties, net name, you delete it. Okay, so no net name is there by default. Okay. Now, what is the thing that we need? We need to put one off-page connector to connect this line and the first page line. So I'm going to go to connectors, and we have off-page connector here. So I can put it like this. Okay. So this is of my off-page 1. And similar to same thing, I'll put it there also. So I can, like rename it. Let us say double click and rename it to V input. Let's say sense. Okay. So V in sense will be my name of this particular off-page connector, and similar to that, V in sense will be here also. So I'll put one more connectors, off-page connector, and if you want, you can like press Control R to rotate it. Okay. And connect it here. So you put it as V in sense. Okay. So if you see, it is telling you that it is already existing. You press yes and it will get connected. So this particular signal is connected to this particular signal, and you can see very easily what will be your output. So what is the gain here? We have gain here 4, right? 3 by 1 plus 1, right? So that is 4. So my input signal is 1 volt. The output signal will become 4 volt. So 4 volt is too much. What I will do is, I will make this input signal to, let us say, 0.1 volt. So the output signal will become how much? 0.4 volt. So shall we measure that and see whether it is working or not? So let us first run the circuit. Let us first run the circuit. So you can see we are running the circuit. My LED is glowing. In page number 2, you can see my output voltage is how much. Let me put a probe here, and we can see we are having a variation in the voltage because it is an AC signal input, right? So I am going to switch off this right now and go to simulate, analyze and simulation, and run transient analysis for 5 milliseconds, let us say, because 1 kilohertz is the signal. So if I do that, you can see we have the output signal, we have the output curve. Let me increase the width. So what was the input? Input was 1 volt, right? Input was 0.1 and output is 0.4, right? 400 millivolts. You can see very easily that it should be zero point 0.4 because we have the signal. Let me just come left side. Okay. Yeah, so the gain of this particular signal is 3 plus 1, that is 4. So that's the reason it is giving you 4 times. If you want to put one more probe, you can put one more probe. So this is my what I PR1. Let me go to first page and see what is my PR1. Probe 1 is yeah, probe 1 is actually the emitter, right? So now I want to do what is my input voltage, that is this one, right? So if you want, you can put probe 3 and let's rerun it. So you can see probe 3 is the here, that is the blue color. I'll just make this little bit thicker and so that you can have a proper understanding, right? Okay, let me change this trace width to, let's say, 4. Yes. So we have the input signal as 100 millivolt. You can see very easily PR3 is 100 millivolt, right? And PR1, that is probe 2, sorry, probe 2 is 400 millivolt. Now it becomes very easy how you are going to measure, I mean, connect your off-page connector VN sense to your this page output, right? And if you vary the gain, let us say I'm going to vary the gain to 5K. So 5K becomes 6 times, right? So the output will become 600 millivolt, right? So the output will become 600 millivolt. So this is how you are able to analyze and simulate the circuit, as well as how to create circuit in multiple pages, with off page connector, on page on page connector, renaming the net name, making your circuit better, and like multiple pages circuits, complex circuits, all these things you can try to do by yourself as per your convenient. Okay, so I'm going to delete all the probes that is needed so that it is very neat and clean circuit. Okay, so if you do have any questions regarding the circuit design and simulation with multiple pages, or like highly complex circuits, and how to connect the net names using net name or something like that, you can put down your questions in the comment box and we shall be able to give you answers. Thank you.